So we're asked to estimate where this first one says where it's greater than 0. So when you see function notation, the f of x, the g of x, this part right here is like your y value. So this says where is the y greater than 0. So here's our graph. This is the y-axis. The y-axis is greater than 0 where I'm drawing right now, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the y values that are greater than 0. So we want to identify this part of the graph. We need to specify the x coordinates. And if you look, it starts becoming greater than 0 at -3, and it ends at 2. So we'd say, -3, 2. That's our interval notation for where the graph is greater than 0. And this next one says, where is the graph less than or equal to 0? So that's where it's negative if we're less than 0. These are the y values where it's negative, so we need to identify two regions where the graph is less than 0. These two that I just circled here, okay? This one and this one. So this one, since the arrow is diagonal, it's going to keep going to -infinity. So we write -infinity. That's the lowest amount we can go on the x-axis. You keep going all the way to the left, you'll eventually get a y value that's still negative. But we need to stop at -3, and instead of a parentheses, I'm putting a bracket because it says it could be equal to -3. So this is this. Okay, and now we need this area. It starts at 2. That's the lowest x value we can have, and the biggest x value we could have is +infinity because it just keeps going and going. So I'm going to put a union, another bracket because we could have exactly equal to 2 because of this line underneath. 2 to +infinity is our answer. Always parentheses next to infinity because you never reach infinity.